This is EGR 101, Week 14, Part 1, What Do Engineers Do? Hi, this is the first of 3 videos that will be our Week 14 lecture. This particular one is on what do engineers do? So let's answer a very basic question, engineers versus scientists. Scientists extend the knowledge about something. We say that they extend the state of the art. They ask questions, and based on the answers to those questions, they discover things that move us forward in terms of our knowledge, either about the nature of things, or if it's the social scientists, perhaps about the nature of ourselves. Engineers, on the other hand, we solve problems. Fundamentally, this is what we do. We use the tools of science, mathematics, chemistry, physics, etc. We use those tools, but we're focused on solving specific problems. We want to build a building, we want to build a bridge, or build an airplane. That fundamentally distinguishes us from the scientists. Now, in terms of what we do as engineers, some of it overlaps what you'll see in science. Research is an area that probably has the greatest overlap. Both scientists and engineers do research. I would say that the difference is scientists are asking more basic question. What is the nature of a subatomic particle? Why does light bend when it goes through a glass of water? As engineers, our research is much more focused. I want to know how a new material behaves, let's say, when subjected to environmental conditions. Or I'd like to discover why this particular molecule bonds to another molecule so I can use it to design a medicine. The big thing with doing research is that generally you're going to need at least a master's and probably a PhD. Development is the other side of this. This is where you're doing designing to solve problems. In development, you could think of using the tools of research to solve particular problems. I think of development as more along the revolutionary lines. It's solving problems where there aren't a lot of examples to work from. I can't take an existing car and scale it up to make a new car. Cars haven't been invented. So again, think of development as more designing of things where there maybe isn't something that is an exact analogy to what I'm building. Testing is the other part of all of this. We need to verify that whatever we design meets the requirements, specifications, and constraints. A part of the reason that we do the testing is to verify that. It's also to give us material properties that we need for our designs. How strong is a piece of steel? How much wear do we get if we have water of a certain flow rate and chemistry going through a pipe? The other type of testing that we do is called validation testing. That's where we determine that what we built or designed really does solve the problem that the customers have. Now, designing is probably where the majority of engineers work. I think of designing as evolutionary designing versus revolutionary. Generally, I'm taking something and I'm using an existing design and I am modifying it to create some new version of it. That isn't always specifically true, but in general, the designing that we see right now is that kind of evolutionary work. I have a car, I have last year's model, I want to create next year's model. I can work from that existing design. Part of designing is I also have to guarantee that I built something safe and reliable. So another part of this is what they call risk management. It's where I ask the question, if this fails, what happens? And that could be if I fail to meet a particular constraint or requirement, what happens to the users? Or if a component inside it fails, what happens? So this is always something that we do. On the one hand, we're creating designs, but on the other hand, we're asking the what if questions. Analysis is where I have an existing design and I'm digging into it to try to understand why it works the way it does. You might see this in reverse engineering, where I have a product and I want to understand why it works the way it does. Or I may have a problem with something. Let's say I built that car. I'm driving it down the road, but it has a vibration. I might use the tools of analysis to understand what's causing that vibration and how to fix it. Systems engineering is a very interesting one. Systems engineering isn't really a discipline. Basically, it's a practice or an activity. In systems engineering, I'm stepping back and I'm looking at the entire product or even family of products, and I'm asking some basic questions about them. What are the overarching things that the customer needs me to do? What are the large scale requirements on this? So most of my work in the past 20 years has been in systems engineering. Let's say using a computer science example. So in computer science, you may design some code to have a particular function, but it's up to us systems engineers, systems architects, software architects to determine whether we're going to do that coding on MATLAB versus Visual Studio or something else. So we tend to ask the big picture questions. Manufacturing is where you build it, and a lot of engineers make real good careers manufacturing. It's quite challenging to take a design and figure out how to do it, have it be repeatable, correct over and over again, and how to do it cost effectively. Operations and maintenance is another part of it. When I think of operations, I could think of, let's say, operating a railroad and determining, how to keep my rolling stock in proper operation, how to operate the engines in the safest manner. Engineers definitely do this kind of work. Operations management, they're the guys that step back and have the bigger thoughts. Is I'm doing it this way, but how do I do it better? Technical support is an interesting part, and you've probably encountered this if you called the MathWorks people for technical support, or maybe even the Cengage people for support on WebAssign. Many times it's engineers that do that technical support because the problems that are coming in are ones that require an engineer's knowledge to understand. Sales. People have made very good careers in technical sales. It's a matter of going out there and understanding what the customer really wants and then matching that to the products or services that will meet their needs. Project management, we teach this in EGR 103. It's putting together the schedules, the timelines, the budgets, etc. in an intelligent way so that we get from the beginning to the end, and we do it within the time and financial constraints of the project. Then consulting. Now the big thing about consulting is you generally need to be a registered professional engineer in order to do consulting. Most every state requires a PE license if you're going to do consulting engineering. I've made some it's been very lucrative when I retired from my previous employer and then did consulting for other healthcare and biopharmaceutical companies. So this can be a very lucrative career. Patent law can be very lucrative. It's quite an interesting specialty because you need to understand the engineering and you need to understand the law. There's not many people that have both those skills. Teaching, here we go. Teaching can be incredibly satisfying. I think the most meaningful work that I've done ever may very well be these years that I'm spending here at the University of Kentucky with you. So I highly recommend thinking about it at some point in your career. People also do training. Generally, training is organized by companies, whereas teaching is organized by, like, a university. Quality and testing really are related to each other. It really goes back to, did I meet the requirements, constraints of my design? How do I ensure that? How do I verify that I've met my requirements? And also, how do I validate that my design meets user needs? Quality engineers think about those things and devise protocols, what are called test protocols, to either confirm or refute that I've met those conditions. That's it on this one. We're going to go into the next lecture, part 2, so stay tuned and we'll see you in a little bit.